Hi, welcome to episode 2 of Learn Roslyn Now. Today we're going to take a look at the syntax tree API and how you can use this API to analyze nodes and figure out sort of programmatically what's going on in a piece of source code. So to start, we're going to take a look at this API by just starting a new console application. And we'll pull down the Microsoft.codeanalysis NuGet package in order to get started. That has sort of all the dependencies and things that we're going to need. So we just do tools, NuGet package manager, console, and we can do install package Microsoft.codeanalysis. And this brings down all of the dependencies and DLLs that we're going to need. Occasionally you're going to need some other special packages for scripting or for Visual Studio extension development, but for the basic case you're just going to need to bring down this code analysis package, and it should have everything we need to get started. So we'll start by running this method, and we'll just use the C# syntax tree API to build our tree. So we can do a C# .syntax tree, and I'm missing some usings here, so we'll bring those in, and we can do parse text. And this is the method. You probably won't use this if you're building analyzers, but if you're doing sort of quick and dirty tree creation and analysis, this is what you can use. So we'll just add some basic stuff into this method. And it's a very simple C# program, and we can see over here that this tree has parsed successfully, and now we can start sort of playing around with it. As I change things like add missing braces, you might notice that the tree still parses. It doesn't throw an exception or break or anything. These trees are very resistant to errors, and if you ever want to figure out what errors are available in your tree, you can just do Diagnostics. It's tree.getDiagnostics, and this gets all the warnings and errors and whatnot in your program. So we're going to get all the ones I think of. Is warning severity is equal to error. So we'll get all the errors, and there should be just one. So we'll just get the first for now. And we can see that it's saying that it's missing a brace, and we can fix that and keep going. So now what we want to do is sort of analyze the nodes inside of this tree, and we can do that using like a combination of LINQ and the API that's exposed. So what we're going to need is the root node to start, and the tree just gets this to us through getRoot. Very easy. And this is basically the same thing as the tree. It's the top level node, and now we're going to sort of go down, visiting the children and grandchildren of this node, looking for things that we're interested in. So say, for example, we wanted to get access to that method. We could just do var method is equal to root.descendant node. So this is all the children and grandchildren and everything that's a descendant of this node. And now we're going to want to filter out for only those of type method declaration syntax. And this will bring in our method. I'm missing a using, and there's only one. So you can see that this just brought in our void method. Nothing too fancy, but we can filter it and change it to class declaration syntax. Now we get the whole class. If we add other things in there like tries, catch, exception. Now we've got that inside of there, and we just want to get the try statement, and now we can perform analysis or issue warnings or do some kind of diagnostic tooling based on this try. So that's the basic traversing these nodes, going down them and filtering them out for the ones you're interested in. You might be wondering, like, how do I know what kind of syntax to filter against? Once again, that always comes down to using the syntax visualizer. So it's just in View, Other Windows, Syntax Visualizer, and you can click on this class program, and we can see, okay, so if I want pieces of syntax that are kind of like this, we're probably going to be looking for class declaration syntax. If I want things that are like this main method, it's probably going to be method declaration syntax. And that's just how you figure it out and figure out what you're looking for. These pieces of syntax all have special custom properties on them based on their type. So a try statement has like a block, for example, and we can just go var block is equal to try statement block. Here it's empty, there's nothing inside of it, but if we just do this is a block, we'll see that that's the piece it's getting. So a question I had when I was starting out is, I've got all these different kinds of syntax, like hundreds of kinds. How do I know what the name of the custom properties on each one of them is? And the quickest way to figure that out is just to type with on it, on your syntax node, and you'll get the options. These are essentially the ways you can modify or change a piece of syntax, and they're all listed for you here. So if we've got with catches, then we've probably got a property on it called catches. If we've got something with finally, we've probably got a property on it called finally. One thing that's important to note about the syntax tree API is that all of these nodes and trees are immutable. So once they're created, we can't change them. Instead, we have to create new nodes and new trees based off our old ones with the changes that we want applied to them. So we can take a look at how that works by changing our method here to change its return type. So method declaration syntax. So we're going to have to start by creating our return type, and we'll just do that by doing, we'll use this syntax factory. The syntax factory is essentially how you create pieces of syntax. It can be pretty overwhelming to use, but fortunately for our case, there's sort of a shorthand where we can just do parse type name and pass in whatever we want. You'll notice there's no fully qualified name required or anything like that, and it's all stringly typed. You can put whatever you want in sort of these syntax trees, and the syntax trees won't know whether or not they're correct until semantic binding and compilation later. So you can create trees that are invalid, that won't compile, and for now we'll trust that string does exist and we can use it. So in order to mutate this, change this method, because we can't mutate it, we have to do var new method is equal to method.with return type, and we'll change it by passing in this new return type. So now you'll see that this new method that we've done has a string as a return type. You'll also notice that there's no trivia on it. There's no space between string and method. In reality, that doesn't matter. As long as the syntax tree has all the correct nodes, the trivia doesn't matter at all. The reason we have spaces when we type code is because the trees haven't been generated and they have to be parsed and lexed out of our strings. So that's something to notice, is that sometimes these trees might look invalid, but in truth, if their actual underlying structure is correct, then they're correct as well. So this is essentially a demonstration of how we created a new method. A lot of people, when they use Roslyn for the first time, what they'll do is they'll try to do this. They'll do method with return type, and they'll say, okay, great, now I can use my new method and everything will be great. But if we just sort of take a look here and we look at this method, we'll see that it's actually still got the old value. And this is sort of like the datetime API. If you've ever used that, when you do something like add days, you have to accept the results from this method. They don't actually mutate the object itself. So that's a really important thing to notice. A lot of people struggle with that when they're starting, and I certainly did when I started. So you definitely want to use these results. But that sort of, I think, brings us to the conclusion of this episode. This is how we can go through trees by looking at their descendant nodes. We can change them by using these with methods that are on each node, And hopefully that should be enough to get most people started. In future episodes, we're going to take a look at rewriting trees, so changing these trees in different ways, as well as using the semantic model and the binding and compilation APIs that are further down the compilation pipeline. So that's everything for this episode. Thanks for watching, and if you have any comments or questions, just leave them in the comments below, and I'll get back to you as soon as I can.